Okay, this is a continuation of the bottom of flap number 3 of your Unit 7 Similarity flip book. We need to finish the upper right-hand corner. We just finished this basic question that talked about how to use the similarity statement to match up corresponding vertices and corresponding sides so we can find different missing angle measures and different missing side lengths. So let's go to the last question here on this page, and I'll scroll this over so we can see it in the middle. Let's see how this works in kind of a story-based problem. A real train engine is 60 feet long and 15 feet tall. A toy model of the train engine is 18 inches long. If the toy model and the real engine are similar, class, guess what? All of our properties of similarity show up now. If they're similar, how tall is the toy? So, the way you solve this problem is we could find a scale factor. That's one way to do it. You saw in our previous example, we figured out scale factors. If one of them is a pre-image and one of them is the image. The other way to do this is to set it up as a proportion, and we're going to do that. That tends to be a little bit faster, and I would rather use proportions if I don't know which is my pre-image and which is my image. So in this case, we're going to set up a proportion. And here's how we're going to do that. Whenever you do a proportion class, you're going to basically draw a line, and then an equal sign and another line, because a proportion, remember, is just two ratios that equal each other. And now we have to set up our proportion properly. It's very important when we set this up we get things in the right place. Otherwise, you're going to end up with a proportion that will give you a wrong answer. So we have to decide, is the real engine information going to be on top or on bottom? We got to pick that. Let's just decide that we're going to put the real engine information on top. Actually, let's do that in a different color so you see it's different from my actual work. So we're going to go ahead, if I can find my cursor now. Okay, we're going to put the real engine information on top. That means our toy information is going to be on bottom. And then we have to decide, okay, are we going to put, we have length and we have height. We have length and we have height. So the question is, which one are you going to put in each of these two ratios? We have to decide. It doesn't matter which is which as long as we stay consistent. So I'm going to go ahead and say, let's go ahead and put the length in this ratio, and let's put the width in this ratio. So now that we've figured out how we're going to set up our ratio, real stuff on top, toy stuff on bottom, length is going to be on the left side, width is going to be on the right side, let's plug in what we know. Well, what is the real length? The real length. Well, the real length is 60. And we're going to write that as 60 feet. Okay, what is our real width? Our real width, actually, you know what? Yeah, our real length, I shouldn't have put width here. I should have put length and height. So this should have been height. Length and height. So our real height is 15 feet. Now for our toy, look at our toy. We know that the length is 18 inches. So here's our toy length. It's going to be 18 inches. And the height of our toy train is what we're looking for. How tall is the toy? That's going to be our variable x. So now let's go ahead and we got a proportion. The most important thing, class, is to set this up right. Once you set it up right, you know how to solve proportions, and you can just go ahead and use cross product property. So 60 feet and x are going to go together. Notice, class, I didn't write the unit of measure for the variable x. You're going to find out it's going to show up all by itself. So 60 feet times x is equal to 15 feet times 18 inches. Now, just like if you found a unit of measure on the top and bottom of a fraction, you can cross it off. If you find the same unit of measure on both sides of an equation, you can also cross that off. So look, feet is in both sides of our modified equation, or our equation that we got from the proportion. So I can actually get rid of feet here and get rid of feet here. And that means I'm left with 60 times x is equal to 15 times 8 inches. 15 times 8 is 270. And we still have inches because we weren't able to cross that off. And now we're going to go ahead and divide both sides by 60. And you're going to end up with x equals 4.5 inches. So we just used the rules of similarity and setting up a proportion to actually find that the toy height is 4.5 inches. These kind of questions, class, should definitely be answered as a sentence. Let's go ahead and write that down. So, the toy height is 4.5 inches. And we know this because we understand the properties of similarity. And if you want to make a little note here in your books, just remember this. Similar. As soon as you see that word similar right there, similar means measurements. Actually, it's put on here. Similar means dimensions are proportional, and that's why we can use a proportion to solve for this. So you found here from the previous example we could use scale factor. You could have also figured out a scale factor here. If you looked at 60 feet long and 18 inches, you could have found a scale factor and then multiplied 15 by that scale factor and came up with the same answer. I wanted to show you both methods, using scale factor and then also using proportions to solve. That is the end of flap number 3.